All right, so we're going to work on our warm-up where here are some squares whose vertices are on a grid. We have to find the area and side length. So for A, I notice the square is 3 by 3. So if I find the area here, it's going to be 3 times 3, which is 9. So my area for A is going to be 9 square units. If I take the square root of 9, I notice that the side length is going to be positive 3. In looking at B is a little bit harder to find the area. So if I notice this is a half of a triangle and I have a half plus a half, that makes 1. So on this side, we have 1. And on this side, we have 1. So my area is 2. But now if I want to get the side length, I have to take the square root of the area to get the side length. So the side length would be the square root of 2. And then 3 is very difficult to find. So what I did was I found the side length, and to find this side length, I used the Pythagorean theorem. So I said that, all right, I'm going to make a triangle here, and that side is 1. And it's a right triangle, and that side is 3. And then we're going to call this side C. So in order to find the overall area, we have 1 squared plus 3 squared is equal to C squared. So 1 plus 9 equals C squared, or 10 equals C squared. And then to work backwards, we could take the square root. And we're only going to take the positive one in this case because the negative one wouldn't make sense. So the side length here is going to be the square root of 10. And then the area, if I multiply the square root of 10 times the square root of 10, that's going to give me 10 units squared. So this is going to be 10. And now we'll move on to solutions that are going to be written with square roots. So now, if I want to solve this equation, x squared plus 13 equals negative 12. I'm going to do the inverse operation and subtract 13 from both sides. Or add 13. I'm sorry, that was a minus, and this should be a plus. So when I do that, I have x squared equals 1. And then taking the square root of both sides, I would have x equals the square root of 1. And then I do have the plus or minus because I could have the positive square root of 1 and the negative square root of 1. And the square root of 1 is 1. So this is going to be plus or minus 1. So there's my final answer for number 1. Then I'm going to work through for number 2. I have rewriting the original equation, x minus 6 squared equals 0. So I'm going to take the square root of both sides and I have x minus 6 equals the square root of 0. Well, the square root of 0 is 0, and plus or minus 0 doesn't make sense because 0 is not positive or negative. So we would just have x minus 6 equals 0. Adding 6 to both sides, I would get x is equal to just 6. And then for number 3, we have x squared plus 9 is equal to 0. So I'm going to subtract 9 from both sides, and we would get x squared equals negative 9. Taking the square root, we would have x equals plus or minus the square root of negative 9. Now I'm going to try to evaluate that on a calculator. And you notice it's not possible. So you can't take the square root of a negative number. They're not defined. You're going to learn more about this in Algebra 2, but right now, that is not possible. Looking at number 4, if you have x squared equals 18, we're going to take the square root of both sides. So x equals the square root of 18. And remember, we would have the plus or minus possibility because it could be the positive square root of 18 or the negative square root of 18. And then we will leave that like this. And number 5, x squared plus 1 equals 18. So using our inverse operations, we subtract 1 from both sides, and x squared equals 17. Taking the square root of both sides, we have x equals the positive or negative square root of 17. And then lastly, for number 6, we have x plus 1 squared equals 18. So to undo the square, we take the square root of both sides. So x plus 1 equals the square root of 18. Don't forget we have a positive and a negative, so I'm going to put plus or minus the square root of 18. And then from here, we got to break it up into 2 equations. So we have x plus 1 equals the square root of 18. That's a positive. And x plus 1 equals the negative square root of 18. So subtracting 1 from both sides, x equals negative 1 plus the square root of 18, and x equals negative 1 minus the square root of 18. And looking at our last example, we're going to look at an example of completing the square. And here's a graph. You can see on a graph, we have to put approximate solutions. So our 2 zeros are negative 4.14 and 0 for y, and then negative 1.86. If we look at our example here where you solve by completing the square, here they just added 2 to both sides to make that x squared plus 6x plus 9, which is x plus 3 squared. And then they took the square root, and x plus 3 equals plus or minus the square root of 2. And x equals negative 3 plus or minus the square root of 2. So here they did negative 3 plus the square root of 2, which was negative 1.586. And negative 3 minus the square root of 2, which is approximately negative 4.14. So now what we're going to do is find the exact solutions by completing the square. So I'm just going to get you a start here. For number 1, I'm going to move the 1 over to the other side. So we have x squared plus 4x equals negative 1. Then I'm going to draw my picture of completing the square. So in my rectangle diagram, I have x squared. And I'm going to take my 4x and split it into 2 equal parts. So we have 2x and 2x. And on the outside, I see that I have x and x in the upper corners. And then this would have to be 2 and 2. So I need to figure out, well, what's this piece that I add to both sides? So multiplying 2 and 2, I get 4. So I'm going to add 4 and add 4. On the right-hand side, negative 1 plus 4 is 3. And then here, x squared plus 4x plus 4 reduces to x plus 2 times x plus 2, or x plus 2 squared. And then I solve for x plus 2 by square rooting both sides. So x plus 2 equals the square root of 3, and it's plus or minus. So to find the exact solutions, we would have x equals, I would subtract 2 from both sides, so negative 2 plus or minus the square root of 3. So to get my answers, I would break it up and say x equals negative 2 plus the square root of 3. This is known as my exact solution, but sometimes I might need to approximate that. So to approximate that, I'm just going to put that in a calculator and press negative 2 plus the square root of 3. And I'm going to round that to 2 decimal places. So that's going to be negative 0.27. And when I approximate, I use the squiggly sign, which is x is approximately equal to negative 0.27. And then I'm going to look for my other exact solution, which is x equals negative 2 minus the square root of 3. Again, this is the exact solution, but we need to approximate that. So I'm going to use a calculator as well. So negative 2 minus the square root of 3. And I get negative 3.73. It's approximately 2. So what I want you to do is solve for 2, 3, and 4. And then I'm going to post your answers briefly. So here are your answers. So make sure you're showing your work and then checking your answers. Do note that if you have negative 5 over 2, you could have wrote that as a decimal as negative 2.5. Or 2 over 9 as 0.2 repeating. So now what I want for you to do is go ahead and do those assignment problems.